so today we're talking about slope. Okay, this is something that you guys covered pretty significantly last year. Okay, slope is the steepness of a line, and it is considered the vertical rise over the horizontal run. Okay, the formula to find slope. The formula to find slope is the difference in the y's over the difference in the x's, and you have to be careful and make sure that you subtract in the right order. Okay. If you're going to do y2 minus y1, you have to do x2 minus x1. You can do it in the reverse order as long as you do both of them in the reverse order. Now, in these particular problems, they have the lines graphed. And so really, if they're graphed and you've got points that you actually know, which we do, you can just count rise over run. Okay, and so like if I started here, I rise 1, 2, 3, 4, and I run 2. So my slope is a rise of 4 over a run of 2, which is 2. But you also need to know how to use the formula, because if they gave you the points, it would be a lot more work to graph it and then count than if you were just to actually use the formula. So we're going to do it both ways. And you can actually do it to check yourself. So if I were going to find my slope, I'm going to subtract my y's, negative 2 minus 2. Subtract my x's, negative 3 minus a negative 1. Remember, minus negative becomes positive. So I end up with negative 4 over negative 2, which is a positive 2. So I've got the same answer both times, so I'm pretty sure that's probably right. So let's look at the next one. We're going to use the formula here. And I'm going to do difference in the y's, 0 minus a negative 1 becomes plus, and negative 4 minus 0. So I end up with 1 over negative 4, which is the same thing as negative 1 over 4, or negative out to the side, 1/4. Okay, those are all the same thing. And then I can check it with my graph. I can rise 1 and run 1, 2, 3, 4 in the negative direction. So 1 over negative 4 gives me the same answer. All right. When you have a slope that is a horizontal line, okay, think of it like you're skiing. Are you advancing anywhere, up or down? No, right? So that has a slope of 0. Okay, anytime you have a horizontal line, it has a slope of 0. Let's do the math. If we worked it out, we have 5 minus 5 over negative 3 minus 1. And so that's 0 over negative 4. And 0 divided by negative 4 is 0. Now, back to my skiing. If you ski and you go straight up or straight down, can you do that? Well, you could go straight down, I guess, couldn't you? But would the result be nice? No, it's not. Okay, so when you have a vertical line, you have an undefined slope. Sometimes we do that. If we were to do the math, okay, we could do negative 4 minus 3 over 4 minus 4. That's negative 7 over 0. Can you have division by 0? No, so that's undefined. Okay? And let's think about that, because this is the thing that people get mixed up the most. If 0 is in the numerator, it's 0. Okay? But if 0 is in the denominator, it's undefined. Think about it. Could I take a 7 and put it into 0 parts? Where would it go? Is there any place to put it? No, you just can't do that. Okay? But you can take nothing and put it into 4 parts, can't you? Yes, what would be in each part? Nothing. Okay? All right. Now, let's notice that, this one on the left here slants to the right. That's a positive slope. This next one has a negative slope. It slants to the left. Your horizontal line has a slope of 0, and your vertical line has an undefined slope. Have you ever done a slope dance? Anybody ever do the slope dance? Oh, look at this slope dance. Okay. All right. When it goes this way, it's a positive slope. If it goes this way, it's a negative slope. 0, undefined. Okay? So positive, negative, 0, undefined. Okay? Do it with me. Everybody. You're going to do it up here by yourself. Okay? Ready? Positive, negative, 0, undefined. Again, one more time. Positive, negative, 0, undefined. Okay. All right, so that is slope. Okay, on this next problem, it says in 2006, 500 million songs were legally downloaded from the internet. In 2004, 200 million songs were legally downloaded. Use the data given to graph the line that models the number of songs legally downloaded, which is y, as a function of the time x in years. So it's even telling me that this right here is years, okay, and my y is number of downloads. Okay, and this is in the millions. Okay, so it says that in 2006 there was 500 million songs, and in 2004 there was 200 million songs. Now it's wanting me to let the years be my x and the y and my number of songs be my y. So I could create two ordered pairs here, okay? And so my first ordered pair would be 2006. There was 500 million songs. And in 2004, there was 200 million songs. Okay, so it wants us to graph this information. So I'm going to let this be 2004, this will be 06, and this will be 08. And then I'm going to do millions here. 100 million, 200, 300, 400, and 500. And so I'm going to graph it. And so in 04, it was 200 million. And then in 06, it was 500 million. So my line looks kind of like that. Next, it wants me to find the slope. Well, that's just going to be like what we did a while ago. There's my points. And so I'm just going to have to put those into my, my slope formula. So I could do 500 minus 200, and then 2006 minus 2004. So that's 300 over 2, which is 150. What does that tell me about what what can I conclude from that? What does that 150 represent? I can't hear you. What does the 150 represent? 150 what? Not people. Per year, because there's a different. Okay, so it's 150 million songs are downloaded per year, right? So 150 million songs are downloaded per year. That's what it tells me, okay? Because it's what's 150 over 1, right? So it's 150 million per year. Now the next question says, if this trend continues at the same rate, how many songs will be legally downloaded in the year 2020? Okay, so we're sitting here at 2006, right? And we're at, what, 500 million, correct? We want to go to 2020. And we want to know about how many songs that would be approximately if it's increasing at 150 million a year. Okay, so what could I do? Okay, so how many years would that be to 2020? 14. So 150 million times 14, what is that? 2,000. 2,100? I think that's right. Okay, so that's 2,100, right? That's the increase, though. What did we start out with? 500, right? So we're going to have to add this 2,100, and so it ends up being 2,600. Well, what is that? Is it 2,600 downloads? Huh? It's in the millions, right? But since this is 2,600, it's now going to be in the billions, correct? Okay, so it would be 2,600,000,000 downloads in 2020. 2,600,000,000 downloads in 2020. All right, any questions on what I did there? Okay, so that's all from last year. Now, I don't know if you guys covered this. I think you might have a little bit. But these next two postulates are very important, especially for this chapter. It says two non-vertical lines have the same slope if and only if they are parallel. Okay, so what that means is that parallel lines have the same slope. Okay, parallel lines have the same slope. The next postulate says that if two non-vertical lines are perpendicular, if and only if their product of their slopes is -1. So perpendicular lines, their slopes are opposite reciprocals. So their slopes are opposite reciprocals. So what that means is that they're reciprocals of each other, and one's a positive and one's a negative. Okay? So, like, if one of them was 3, then the other one would be 1/3. -1/3, sorry. One has to be positive, one has to be negative. Okay? What if one of them was 1? What would the perpendicular one to that be? -1, right? 1 flipped upside down is 1, right? I think they have to be opposite signs. What if one of the slopes was undefined? What would the other one be? 0. Okay? So if they're perpendicular, then their slopes are opposite reciprocals. Okay, so in these next few problems, we're going to determine whether these lines are parallel, perpendicular, or neither. Okay? All right, so I have to first find the slope of AB, and then I have to find the slope of CD. So I'm going to find the slope of line AB, and then I want to find the slope of line CD. And remember, it's the difference in the y's over the difference in the x's. So I'm looking at AB first, and I'm going to do 7 minus a -5 over 4 minus a -2. Now remember, when you minus a negative, it becomes plus. Okay, so that ends up being 12 over 6, which is 2. Then I'm going to do CD. I'm going to do -2 minus 2 and 8 minus 0. So that ends up being -4 over 8, which is a -1/2. So if one of the slopes is 2, the other one's -1/2, what does that tell me about my lines? They're perpendicular. Now, how would we write that? If we want to write that, we would say that line AB is perpendicular to line CD. That's the appropriate way to write that. Okay? I noticed that on your test, some of you, even when you were stating like AB was congruent to CD, you would write line AB is congruent to line CD. So that's awesome for English class, right? But we're in math class, and we need to know how to do that in the right symbols, right? So you would do the correct notation for line AB, the congruent symbol, and the correct notation for line CD. You know what I'm saying? So this is how you would state things are perpendicular in this case. And you would do the same thing for parallel. All right. Here's another one. I'm going to find the slope of AB, and I'm going to find the slope of CD. Okay, so again, it's the difference in the y's. -4 minus a -7 over 4 minus a -8. And that's going to be 3 over 12, which is 1/4. And I'm going to do CD. 7 minus a -5 over 1 minus a -2, which is 12 over 3, which is 4. Parallel, perpendicular, are neither. They're reciprocals, but they're neither. Why are they neither? They're reciprocals. They're not opposites, are they? Okay, one of them has to be positive, one of them has to be negative. So this one would be neither. Okay, try the next one by yourself. Okay, so what do we get for the slope of AB? 1/3. Okay, what about CD? 1/3. What does that tell me? That they're parallel. So remember, the appropriate notation would be AB is parallel to CD, just like that. So if they have the same slopes, they're parallel. They have opposite reciprocal slopes, then they're perpendicular. All right, last two. This one's super easy. Graph the line that has the slope of -2 and passes through the point 3, -1. So if I'm going to graph this, what's the first thing I got to graph? The 3, -1. So from the origin, 1, 2, 3, and down 1, right? Okay, and then I have to do my slope. Well, my slope's -2. What is that?
Rise -2.
Rise -2, run a +1 from where? From that point, right? So I'm going to rise -2, which is down, and run -1, right? Could I go up 2 and to the left 1? I could do that too, couldn't I? Go up 2 and to the left 1, or down 2 and to the right 1, couldn't I? Okay. And so there's my line. As long as I go negative in one direction. And mine kind of jags a little bit. It should be one straight line, but it's hard to draw in here. Okay, any questions on that? That's super easy. Now let's get a little bit more difficult. Graph the line that contains the point P, which is at -2, 1. So go ahead and graph that down over to the left 2 and up 1. There's point P. And it's perpendicular to line JK, and it gives us the coordinates for J and K. What do I need to do with that? Do I need to graph J and K? I could. But what do I need from that? Because I want my line to be perpendicular to it. I need the slope of JK, but then my slope is going to be the opposite reciprocal of it. So I could graph JK if I wanted, or what else could I do? Okay, so I could find the slope of JK. So my slope of JK, remember it's the difference in the y's, -2 minus 4, over the difference in the x's, 0 minus a -5. So it ends up being -6/5, right? Okay, so then the slope of the line perpendicular to JK is going to be the opposite reciprocal, which is a +5/6, right? So then I'm going to come over here from this point, and I'm going to rise 1, 2, 3, 4, 5, and run 1, 2, 3, 4, 5, 6. And so there, terrible line, but anyway. A little bit better. There. Now, some of you wanted to graph JK, and you could. Let's see, J is located at 1, 2, 3, 4, 5, 1, 2, 3, 4. K is located at 0, -2. And you could do it to test it, couldn't you? And they're perpendicular, okay? And you could even get your slope from that, okay? But you don't necessarily have to. All right, so we learned that to find slope, the formula, y minus y over x minus x, right? You gotta make sure you do both of them in the same order. Okay, let's do the slope dance real quick. What's this? Positive, negative, 0, undefined. Okay, and two lines that have the same slope. What do we know about them? They're parallel. What about slopes that are perpendicular? What do we know about their slopes? Opposite reciprocal. Okay. All right, and when you've got 0 in the numerator, what's your slope? 0. If the 0 is in the denominator, it is undefined. If it's 0 over 0, it is 0 is in the denominator. Anytime 0 is in the denominator, it is undefined. Okay? All right, it trumps anything else. Okay? All right. So, look real quickly on your page. Let's see, page 192. I want to just show you something real quick on the directions. Okay, it's kind of hard to see, but like on 5 through 8, it says determine whether they are parallel, and then it says graph each line to verify your answer. I'm not going to make you graph each line to verify your answer unless you want to. But when you get to like numbers 9 through 11, it says graph the line that satisfies the condition. You have to graph that one, okay? But if it just says graph to verify, you don't have to do that, okay? All right. Any questions?